All right, in problem number 1, we're looking for the minimum height that a marble must drop, so that's this height right here, to reach the highest point in a track, so that's right here, without leaving the track. So this has a lot of different things. First off, anytime you're picking one height to a next, a great strategy is in change of heights, you're having a change in energy. You have potential energy at the top, and then you have different types of energy at the other location. So a great strategy, changes of height almost always are energy. Now we have some other things in here because what we added in this problem is we have different types of energy. At the top, we only have potential energy. Is there work? Well, in this one, there actually is friction, but it is rolling friction. We learned today in class that rolling friction does no work. Now, at the top, where that marble is right here, what is the object doing? Well, it has a height, so it also has potential energy. It's moving, so it has kinetic energy, but it's a marble, so it also is rotating. So now, I got to kind of go through and try and solve this. So let's plug in our equations from this. Well, I know UG is mgh. UG at the second location, which we have right here, is mgh, but the answer wants it in terms of r, so that's going to be this height is the diameter, which is mg2r. Kinetic energy, well, kinetic energy is 1/2 mv squared, and rotational kinetic energy, the one we learned today, is 1/2 I omega squared. Now, the problem here is you have rotational variables and everything else is linear. So let's convert my rotational variables to linear. So what I could do here is I'm going to do 1/2 I should have given it to you, but that is 2/5 mr squared for a marble or a sphere. Then we could also do angular going to linear is angular times r. So omega equals linear over r. So this is v over r. And then I have to square it. Then I can rewrite everything. mgh equals, I'm going to put the 2 out front, 2mgr plus 1/2 mv squared. Now, practicing our algebra, is there an m in every term? Yes. These are squareds, cancel those are squared, so let's rewrite this equation here. This becomes gh equals 2gr plus 1/2 v squared plus multiply those two fractions there, that's going to be 2/10 v squared. Now, the only issue is I don't know that velocity. So where is this velocity going to come from? Well, we're limited here. We have a minimum height. Why is there a minimum height? Because if you go too slow, so you're going to have a minimum speed, we said the ball will fall down. Okay? Now, this is a ball going around a loop. If the ball falls down, if you go too slow, the normal force is 0. We also have circular motion here. So maybe we can find that velocity in circular motion. So let's look at our ramp. I have the ramp going up like this. There's the ball. We always have gravity. Okay, the surface is touching it, so I have the normal force. So I can do my net force here. So F net equals MAC. This is going to be mg plus Fn. They're both to the center. We make the center positive. Equals m, then that becomes v squared over r. It's been a while, but we said Fn is 0, and again, I'm showing all the steps for these. So I'm left with mg equals mv squared over r. Masses cancel, so I'm left with the velocity squared equals gr. Now, why didn't I solve for velocity? Well, if I went over here, I see that these are already velocity squared, so I can plug that in there. I'm also, before I do this, before I plug that in, I'm going to combine these fractions. So 1/2 plus 2/10, you need a lowest common denominator. This is 10. To do that, that would be 5. So here I have 7/10 v squared. Then I plug in what v squared is to here, and I have 7/10 gr. Doesn't matter if it's lowercase or uppercase, they're both the same. So rewriting this equation, gh equals 2gr plus 7/10 gr. Well, again, all kinds of stuff cancels. This is great. This g cancels that because it's in every term. So I'm left with h equals 2r plus 7/10 r, or 0.7. So h equals 2.7 times the radius. Then you could go back and you should have checked ourselves. Where's my answers? And here we go. I have 2.7 r.